This is the makeup video for the reaction rates lab. Unfortunately, this is not a lab that can be repeated very easily outside of class time. It requires too much setup with chemicals, heated chemicals, cooled chemicals. So if you weren't here for the lab in class, you have to do it using the video. You will need this paper before you start this video. If you don't have it, stop the video, get the paper. Otherwise, it won't do you much good. Also in this video, I'll just be getting your data for you. I won't be telling you what the independent and dependent variables are. You need to figure those out for yourself. Remember, the independent variable is the thing that you change, and the dependent variable changes because of what you change. So we will be getting that data right down here. Our procedure tells us how to set up. That's what we're going to do right now. As you can see, we need to set up our well plate. That is this right here, our well plate. With these concentrations, we will change the concentration of potassium iodate. First well will have 5 milliliters of potassium iodate, 0 water. Then 4 to 1, then 3 to 2, 2 to 3, 1 to 4. My main chemicals I'm using, as it said, is potassium iodate. And then we also have something called sodium metabisulfate. These are my two chemicals right here. The last chemical we'll be using is plain water. We need to make sure not to cross-contaminate at all. Only mix chemicals when we are supposed to, otherwise we ruin our experiment. So I'm going to set up my plates now. I need 5 milliliters in my first well of potassium iodate. 5 milliliters. And then I go 4, 3, 2, and 1. 4, 3, 2, and 1. Now my first plate, if you read the directions, says that it has no water. It's pure potassium iodate. Second plate has 1 milliliter of water, so here's 1. That makes it a total of 5 milliliters. Every plate has a total of 5 milliliters of liquid. The ratio of potassium iodate to water is what changes. Plate number 3, well number 3, gets 2 milliliters of water. Well number 4 gets 3. Well number 5 gets 4. So I have the same amount of liquid in every well with different concentrations of potassium iodate, KiO3. Now that I've done that, I get to mix 2 milliliters of sodium metabisulfate into each well and time the reaction. For the timer, I'm relying on you to use YouTube intelligently. So you have a timeline on any YouTube video, so you should very easily be able to count the amount of time by dragging that back and forth, pressing rewind, whatever you need to do to figure out exactly how much time each of these reactions take. Okay, I've got my 2 milliliters of sodium metabisulfate. I'm going to add them. Keep an eye on the time mark at the bottom of the video the second I add this, the second I add it, and then you count to see how quickly the reaction takes. Here we go, adding. If you did not mark the time, go back. Remember, this is plate number 1. This had 5 milliliters, and our reaction has started. You can see the reaction once it starts happens pretty quickly. Okay, now we're going to do plate number 2, well number 2. Again, pay attention to the time mark on the video below. If you don't catch the time signature, go back. Adding my sodium metabisulfate now. You should be watching the time at the bottom of the video. Our reaction has started. Going to zoom in for you for the rest of them, since you don't need to see me pulling syringes over and over again. Going to number 3, I'm getting my 2 milliliters of sodium metabisulfate. 2 milliliters. Adding it to plate number 3. Now. Again, you should be watching the time at the bottom of the screen. Watching your time. Again, if you need to rewind, there you go. Reaction starts right then. It is an interesting reaction to watch, and like I said, it is more interesting in person. I am sorry you missed it. All right, getting my 2 milliliters for reaction in plate number 4. Here we go. Adding to plate number 4 now. Watching the time at the bottom. Certainly you've already noticed that the time increases. The reaction rate slows down, and the time that it takes for the reaction to happen increases as our concentration decreases. That should give you a hint as to what kind of pattern you're going to see on your graph. There we go. If you have been marking your time from the second the reaction starts to happen, that is absolutely fine, as long as you did it the same way every time. If you've been marking the time from when the reaction is complete and the whole thing has changed color, that's fine as well, as long as you've done the same thing every time. Consistency is the only issue in that case. All right, I'm going to inoculate my last plate with 2 milliliters of sodium metabisulfate. Injecting now. You've probably already figured out this one will take your longest. If you've missed any of this data, of course, you can go back, rewind the video, find the data you need. There are 5 data points that you are required to record. The time that it took each reaction to happen. If you find that one of your later times is actually faster than one of your earlier times, something has been recorded wrong, you might want to go back and look at the video, because every reaction should take sequentially more time throughout. Fastest to slowest. Fastest up here, slowest on the bottom. As you can see, this one's already taking a significantly longer time. There we go. Like I said, pretty cool transition to watch. Okay. Everyone else in class at this point rinsed out their plate. And we flip to the back page and we do a slightly different experiment. On the front page, we change the concentration. On the back page, we are changing the temperature. We are still using 2 milliliters of sodium metabisulfate every time. We're using 3 milliliters of potassium iodate. 3 of those milliliters are room temperature. I'm going to tell you these temperatures right now. You'll have to write them down. If you miss them, you're going to have to go back in the video. Our room temperature, potassium iodate, is 24 degrees. I've already measured these. They're 24 degrees. Our heated potassium iodate, that's up here on our hot plate. That is 71 degrees. 71 degrees. That is our hot potassium iodate. Our cold potassium iodate here, that is 9 degrees. 9 degrees. I'm going to inoculate our 3 plates, each with 2 milliliters of sodium metabisulfate. Plate number 1. Plate number 2. Plate number 3. 2 milliliters each of the sodium metabisulfate. First, we will do room temperature potassium iodate. 3 milliliters of our product. Again, the second I start adding, you look at the time on the YouTube video, starting now. There you go, right there. Now we're going with the hot potassium iodate. Three milliliters. You might want to take a guess as to what will happen. Will the reaction happen faster? Will it happen slower? Adding hot right now. Again, use the timer on YouTube. Pretty quick. Now cold. Hopefully your intuition is telling you how this one will be different. Hot went faster than room temperature. So what will happen with cold compared to room temperature and hot? Here we go. Cold potassium iodate. Start your timer now. There's your reaction. Again, if you measured to the split second the reaction started, that's fine. If you measured to when the reaction was complete and the full color change had happened, that is also fine. You should now have all your required data on the backside. Hot, room temperature, cold. The temperatures were the exact same as they were on the front. As I had said. I will recap that really quick. Our hot was 71 degrees. Our cold was 9 degrees, and our room temperature was 24 degrees. That should give you all your data. All the other graphing and questions are your responsibility. Good luck. Thanks.